Hey there, and welcome to today's Explainer. We are jumping right into a totally foundational concept in algebra, linear equations. We're going to break down the core definitions, tackle some practice problems, and look at the real-world solutions you need to just completely demystify the math. Okay, let's dive straight into this. Seriously, have you ever looked at a perfectly straight line on a graph and wondered, what exactly makes it mathematically straight? Like, what are the underlying rules keeping it from curving, bending, or just zigzagging all over the page? Keep that question right in the back of your mind as we get into the formal definitions. So, here's our roadmap for today. 1. We'll meet the linear equation. 2. We'll look at the forms of the equation. 3. Graphing the straight line. 4. The balancing act. And 5. We'll wrap up with some practice problems.
Section 1. Meet the linear equation.
Let's clear up the mystery behind this terminology right off the bat. A linear equation is simply an algebraic equation where the highest power of the variable is always 1. That is the absolute golden rule here. You might also hear it called a one-degree equation. And honestly, the coolest part? When you graph an equation that follows this exact rule, it always, without fail, results in a perfectly straight line. Hence the name, linear.
But, to keep that line perfectly straight, we have to follow some pretty strict constraints. First, like we just talked about, variables are only to the first power. You're never going to see an x squared or a y cubed here. Second, variables are never multiplied together, so no x times y tucked into the middle of your equation. And third, absolutely no variables in denominators. That means no fractions where an x or y is just sitting at the bottom. Oh, and no square roots or cube roots of our variables either. It is a strictly one-degree environment, no exceptions. And this brilliantly illustrates the difference. Look at y equals 8x minus 9. Both variables are just to the first power. It's clean, it's linear. But then look at y equals x squared minus 7. That little second power, it completely breaks our golden rule. That is a nonlinear equation, and let me tell you, it will definitely not draw a straight line.
Section 2. Forms of the equation.
Just like we have different outfits for different occasions, a linear equation can wear different mathematical formulas depending on what we actually need it to do. There are 3 primary forms you're going to run into. First up is the highly popular slope-intercept form, y equals mx plus c. Here, m represents the slope, basically how fast the line rises or falls, and c is the y-intercept, which is exactly where the line crosses that vertical y-axis. Then we have the point-slope form, which is fantastic when you only know one single point on the line and its slope. And finally, the standard form, ax plus by equals c, where a, b, and c are just your regular numbers. The wild thing? They all represent the exact same straight line, just dressed up a little differently.
Section 3. Graphing the straight line.
Let's move on and see how this builds into translating our math into a beautiful visual graph. Let's say we start with an equation in standard form, like x minus 2y equals 2. Well, the very first step to graphing this is usually converting it into our graph-friendly slope-intercept format. By moving x to the other side and dividing by -2, we rearrange the whole thing into y equals x over 2 minus 1. And trust me, this makes our next step so much easier.
Now, we just get to play a little game of substitution. We plug different numbers in for x to see what y pops out. If x is 0, y is -1. If x is 2, well, 2 divided by 2 is 1, minus 1 is 0, so y is 0. We just keep doing this to generate coordinate pairs, like 2, 0 and 4, 1. Once we've got a few of these pairs from our table, we simply plot them on our grid, connect the dots, and boom, we've drawn our perfectly straight line.
Section 4. The balancing act.
All right, now we transition to the core methodology of actually solving a linear equation for an unknown variable. To do this right, you really have to imagine the equation as a vintage weighing scale. Right in the middle, acting as the pivot point, is your equal sign. For the scale to remain perfectly balanced, whatever mathematical operation you do to one side of the equation, you absolutely must do to the other. If you add 5 pounds to the left, you got to add 5 pounds to the right. It's all about preserving that mathematical balance.
Let's see this balance in action with the equation 3x minus 2 equals 4. Our ultimate goal here is to isolate x. First, we want to get rid of that minus 2. So, we add 2 to the left side, but remember our balance rule. We have to add 2 to the right side as well. That gives us 3x equals 6. Next, to get x completely by itself, we divide the left side by 3. Doing the exact same thing to the right side, 6 divided by 3 leaves us with x equals 2. We just isolated the variable without ever disturbing the equilibrium.
Section 5. Practice problems and solutions.
Okay,
You now have all the foundational tools, so let's apply them to some practical, real-world word problems. Here's our first challenge. The sum of two numbers is 44. If one number is 10 more than the other, what are the numbers? I really want you to think about how to frame this mathematically. How do we take everyday English words and turn them into our variables?
Now, what's really interesting here is how smoothly we can translate logic into algebra. Let's just call our first unknown number x. The problem says the second number is 10 more than the first, so we'll call that x plus 10. Their total sum is 44. So we frame it up. X plus 10 equals 44. We combine our variables to get 2x plus 10 equals 44. Then we balance. Subtract 10 from both sides to get 2x equals 34. Divide by 2, and x equals 17. So our first number is 17, and our second number, which is 10 more, is 27. It's simple, logical, and honestly, pretty elegant.
Let's hit one more practice problem to really solidify this in your mind. 6 times a number is equal to 48. Find the unknown number. This one is a bit faster, but I promise the process is exactly the same.
So, the crucial point is all in the framing. 6 times a number translates perfectly to 6x is equal to 48 is simply equals 48. Now we have our equation 6x equals 48. Time to apply our weighing scale rule. To get x alone, we divide the left side by 6. To keep the perfect balance, we divide the right side by 6. 48 divided by 6 gives us our final answer, x equals 8.
Wow, we've covered a lot of ground today. We learned that linear equations are strictly one-degree equations, meaning their variables never have an exponent higher than 1. And this mathematically guarantees a perfectly straight line on a graph. We've seen how to balance them, graph them, and solve them. But before we wrap up this explainer, I want to leave you with a little thought experiment. If an exponent of 1 makes a straight line, what kind of shape do you think an equation with a power of 2 creates? Think about it, and let that spark your curiosity for your next math adventure. Keep balancing those equations, and we'll see you next time.